Now I have.
Okay, well, welcome to the February 3rd, 2026 session of Tapper and HamSCI technical session. My name is Dave, KV0S, and this week I've been doing some cleanup on some of my um V-links and wiping them clean and reinstalling everything. Just um, I I don't know if it's for practice or uh, whatever. Notice a few things are work differently,
Mm.
but I got it figured out.
Mm.
So anyway, that's what I've been doing mostly, and then actually dealing with uh, family things around the house, and so that's taken some of my time too. So next on the list is Nathaniel, W2NAF.
Thanks, Dave. Like always, I am doing a lot on all the different projects and trying to move everything forward, and it is gradually coming. Um, Today, abstracts for the HamSci workshop were due yesterday, and we had a committee meeting of the workshop committee this morning, and that went very well. And they are getting the hotel information out. I know Bob Inderbitson sent it out today to Gary, and he's going to work on getting on the website, I think. And then we went over the abstract and started to sketch out the agenda. And I think there were a few people on this call that we were wondering if they might be interested in still contributing an abstract. Maybe they're Rob Robinette or Paul. If you're interested in submitting an abstract, we'd be very, happy to have you come and talk. And I believe we have adequate support available to, you know, fund your travel, and we would love to have you. And Phil Karn, I know they were interested in having you come as well, and yeah, other people on here may also have things to contribute. Maybe Scott Newell, uh, and Dave Witten. We're I'm planning on. I'd love to have you come too. We have our meeting tomorrow morning with Jackson, and so I thought that you and Jackson together could do a poster and a demo, and so we'd have you
Mhm.
there. So yeah, so that's pretty much it. And the other thing, I met with the IT department at the university today, and we're continuing to discuss the remote access system for the personal space weather station. And they found a project called Mesh Central. And I don't know if you've heard of Mesh Central, Rob, but it sounds like it might be a solution that both will meet university requirements and actually it might actually be better for doing the remote access than what we have right now. So maybe we can talk about that in the open session. Back to net.
Okay, sounds like interesting stuff. Next on the list is Dave, KD0EAG. Go ahead.
I just hid my screen. I'm just plugging along. I've been doing various experiments related to the magnetometer, both as a local and as a kind of cloud resource, with prototyping ideas for what Nathaniel was just talking about. Yeah, I guess we're going to have a meeting in the morning, for active monitoring dashboard. Otherwise, I have been doing something, a lot of something, but I'm not always quite sure what it is come the end of the day. Um, Maybe a little bit of 3D printing and miscellaneous and other. Uh, so staying out of trouble mostly. So that's about it for me.
Okay. And next on the list, we have iPad 2 again.
Someday I'll figure out how to change that.
Yeah.
Good evening, everybody. This is Bob, W1XP. And well, we had some interesting weather. We got 12 inches of or 18 inches of snow on top of 12 inches of snow. And that makes a lot of snow. And but everybody's getting around fine and everything. We really didn't have any real problems with power or anything here. But I did notice today the thermometer finally got up to at least 33 degrees. But
Uh,
the other day, the dog and I went out and waited around in the snow for an hour or so, and I put up an 80-meter vertical wire that I'm evaluating as a an antenna for the Whisper Demon here. So that's something in progress. Anyway, I hope everybody else is making out okay in this bad weather and cold weather. Back to net.
yes. Uh, and next on the list is Paul, WB6 CXC. Go ahead.
Yeah, hi everybody. I showed this little fox hunt thing just because the board came in today, and I thought I'd build it up because I have finished with the X88 888 board. Getting it to the point where it's ready for some review. Got some last minute help from Franco on some of the signals I just wasn't sure about, and he's been very helpful there. And at the end of, when we're done with the check-ins here, if anybody wants, I'll do a little show and tell of how the board looks. And
Good.
then back to net.
Very good. So that's good news, Paul.
Oh, I'm
Uh,
sorry. One more thing, Nathaniel. Yeah, I would be. I'll talk with you about um, a presentation of some sort. I'm thinking it'd really be good to do some time of flight work
So
as far as you know
Mike,
talking about it.
yeah, Michael Howen's doing his timing thing. So yeah, time of flight is different. Yes, you'd very much like a time of flight presentation. Absolutely.
Yeah, okay, we'll
Yes.
talk about that.
Very much so. Yes.
Okay, now back to you, Dave.
okay. Next on the list is Dave H, W6OQ.
Good evening, everyone. Yeah, so I used to live in Ohio, and I'm glad I don't anymore, from what I hear. Plus, my sister still lives there in Columbus, and she's pretty far south, and they usually don't get much snow, but I guess they had 12 to 14 inches last I heard from her. Anyway, no radio stuff this week, just recovering from my hand surgery for the carpal tunnel last Monday. Alrighty, bye.
Very good. Next on the list is Dave Julian. Go ahead.
Well, good evening, guys. Not much going on over here other than trying to shovel out of the snow as well. It's like everybody else. Got a new service monitor, IFR 2975 or some stuff that I'm trying to figure out. But other than that, that's about it. Back to the net.
Okay. And next on the list, we have David McGaw in one HAC. Go ahead.
Good evening, everyone. Well, we got our share of snow, but long since dug out at this point. Primarily, the big news has been very, very cold, between like 0 and 10 mostly, teens anyway. But that's yeah, whatever. It's winter. Um, Happy Groundhog's Day, except in UT we've already passed it. Um, Still working on our CubeSat ground station. That's coming along. And then, we did, as I've mentioned before, our cinema spacecraft NASA mission was approved. And there's supposed to be a citizen science initiative attached to it called Movie. And I'm hoping to do a presentation about this because at the HamSCI workshop. Nathaniel, did I get in on the list?
You know, I think actually that's a good point. I don't think you submitted through the actual main abstract system.
Right.
And so
I
can you
wasn't clear when the deadline
oh
was either.
it was so if you could just submit that as soon as possible,
I
we will
will.
get we will get you in.
Okay. Yeah, it's a
Yes.
very exciting
Yes.
mission and very active citizen science once it gets funded.
Great.
Yeah, and I did mention that we aren't funded yet. You had asked that question. So
Yes.
if you can
Yes.
lend support, it would be
We will
appreciated.
absolutely.
Okay. And yeah, it's going to include radio, magnetometers, all sky cameras, a whole bunch of other things. And both Nathaniel and Christina have already contributed to the planning of this. So I'm looking forward to being able to give a good presentation to introduce it to the greater community. So I guess that's about it from this side. Stay warm.
Okay, well, we have somebody retransmitting some signals, so
Let's see.
if you could mute.
I'll just mute everybody and then unmute yourself when you need to.
Okay, can you hear me?
Yes.
Okay. And next on the list is Gary, AF8A. Go ahead, Gary.
Yeah, good evening, everyone. I've been trying to stay out of trouble myself between getting ready for Hamcation in Orlando, working on the workshop. We got some Grape 2 refreshes that got to happen. Comment to Dave McGaw. David, I will try and send you a link to that to the abstract submission form because I've already closed that down on the website because took the space and I got the hotel, airline, and a couple other bits of information on the HamSCI workshop page. So let me look for
Okay,
that while
very
we're
good.
talking. And
And
back to
actually
net.
the best thing, Dave, if you can just email Gary your abstract information, that's probably the best thing to do. And then he
Oh,
can add
fair
it.
enough.
Yeah, he'll add it directly to the website or to
Sounds
the
good.
spreadsheet we have.
Yeah,
So,
I think we had some more come in today, Nathaniel. So if you could just download the whole thing out of your OneDrive and just send it to me, and I'll find the one or two that got added at the end,
okay, great. I will do that right
and I'll
now.
add David's. So
Wonderful.
all I
Oh,
ask is sooner rather
Yeah,
than
and
later, because
yeah.
we're putting 5.5 pounds of potato in a 5 pound bag. So
And yeah, so Paul, you can just email your abstract to Gary.
okay. Next on the list is Jay Schwartz, WB8 SBI. Go ahead.
Yeah. Good evening, everybody. Regarding the hotel reservations, yes, I can confirm that they are up on the HamSCI website. I checked it just about 10 minutes before at about 8:50 tonight, so it's all there and it's good. The only thing technically I've done this week is my wife's Dell laptop was making a horrendous noise, so I had to take it apart, clean the cooling fan in it, and now it's back to being the fan is back to being quiet the way it should be. Uh,
Yeah.
so that's the most exciting technical thing I've done since last we met. Regarding the weather, I saw a rather detailed scientific analysis about what's happening with the cold weather coming down from the Arctic. And the forecast is it's probably going to be here at least till the end of February. It might even be till the end of March. Uh, it's 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 that bad. It's that serious of a climate event. Anyway, and with that, everybody take care, stay warm. 7-3, back to net.
Okay. Next on the list is Ken Hill, VE6 AGD. Go ahead.
Oh, hi, everyone. I don't have too much to report other than I have the Pi software talking to the magnetometer sensor, and I'm about to install the sensor into the pipe. I wasn't able to find any PVC pipe here in Alberta, but I was able to get some ABS pipe. I think that should work okay. So that's about all I have to report on.
Very good.
Oh, and I should thank the author. I forget the guy's name, the author of the software, but he helped me a lot to get it up and running. There were a few changes that had to be made, but it's up and running.
Yep.
Thank you.
That'd be Dave Whitten.
Yes, Dave's here.
Oh, is Dave
You're
here?
muted, Dave.
I'm sorry. I was having difficulty hearing that, and
He said he thanked you for the software on the
oh,
magnetometer.
oh, well, of course, of course. I wish it was better than it is, but we're working hard to make it better. We got some new stuff coming along.
Okay. Thank you.
Very good. So next on the list, we have Mark in A6VI. Go ahead.
Okay. Hear me?
Yes, now we can hear you.
Oh, okay, yeah. Just trying this new mic here. Don't have much to say. We've been lucky, had very little snow. Oh, actually, good morning for me, and it's good evening for you guys. We've had very little snow at all, but we've been in the teens and below 10 for like a month and a half now. So it's been kind of chilly out to do anything, but the only thing I've been really playing with is Mestastic and Mescore. We got nothing like that in Korea. So I'm being the first one to set up a whole system here around my area. It's trying to get the guys involved in it. So I'm just trying something different, make them think a little bit out here.
Very good. I'm glad you're here. Next on the list is I called on Paul, so it'd be Phil, K9Q. Go ahead, Phil.
Hey guys, not too much to report this week. Probably have something to say later. Back to net.
Okay. Then next on the list would be Scott Newell, N5 TNL. Go ahead.
Hey guys, too busy at work to do any radio stuff, so nothing to report this week. Back to net.
Okay. And next on the list is Tom, N5EG. Go ahead.
Okay, good evening, Dave and the group. Well, January was a total bust, so hopefully in February I'll get started back on the project. Back to the group.
Okay. Well, glad you're here. Next on the list is Rob Robinette. So go ahead, Rob.
Hello. I don't think I have a lot that's relevant to this group that's happened in the last week. I'm mostly working on database stuff, revising our databases and learning more about databases than I ever imagined. I never wanted to, but there may be, there may be at this point some opportunity for us to offer database services that are more easily accessible, debuggable than we can do through the University of Alabama site. So now that I've dealt with 11 billion spots from WhisperNet, maybe I could be helpful to something from this group.
Very good.
Anyway, back to next.
Okay, and then I noticed I skipped over Bob, WB0VGD. Go ahead, Bob.
Good evening, Dave, and it's good to be back. I've lost track of you guys for a while and just wanted to tune in and see what's going on in the HamSCI community. It was a good month. I've been doing a lot of channel sounding with my Flex radio and Kiwi SDRs and coming up with channel impulse responses and having fun with that. I gave a talk several weeks ago at ERSI at the National Radio Science meeting, and it was in a point-to-point propagation meeting session they had. So had a lot of fun with that. So, but I've been doing a lot of experiments with it and mainly on the 60-meter band, running experimental transmissions with it.
Very good. So I think I've called on everybody.
I
Um,
my wife actually wanted me to give an update for her too.
oh, okay.
So she has been continuing to meet with her lab group working on the ground magnetometer in the lab. And so this is a photo from today. So this is Christine Zagziski, KE2 FDW. There's Majid Mukhtari. And we have the ground magnetometer set up on this in this set of Helmholtz coils. And you can see it's on a little mount that Majid 3D printed. And then that is going to the Raspberry Pi over here, and that's taking data using Dave Witten's software. The Helmholtz coils are being driven by this apparatus over here. So what you can do is we have this arbitrary function generator, and they can send it any waveform you want. So they've done some calibration runs where they've done some square waves, they've done some triangle waves, basic things like that. But then we've also taken actual measurements from the Gannon geomagnetic storm that I made with the magnetometer I have in my backyard. They digitized it and they now have it set so you can send it back through these Helmholtz coils and basically replay the geomagnetic storm and record it on the magnetometer. So the point of this is to basically have an end-to-end lab test and demonstration, working with everything. And my wife's going to be doing a presentation at Hamcation on this. And then they're also going to do a poster and demonstration at the HamSCI workshop. So, and they have that. They have, let's see. There's a close up of the Helmholtz coils with they used to have a set of these journals, books that it was sitting on. So Majid printed this thing, which he calls the book eliminator. That's named after Dave Witten's Pi eliminator. So this is the book eliminator. And then that is the Gannon storm data that I collected with the magnetometer in my backyard, but that is on the system. So you can send it to the arbitrary waveform generator. And then they have this video, which there's no words to it, but Rachel's planning on showing it at Hamcation and explaining what's going on. You can see here that the arbitrary waveform generator is sending this. This is showing on the oscilloscope that it is in fact being sent. They're able to measure the voltage and current going through the Helmholtz coils over here. They're able to watch the ground magnetometer measurements over there, and that's all happening. So you can see right now that the ground magnetometer measurements are all done in a Linux terminal, and there's no real interface besides the command line to make that run. And so that's the project that our student Jackson and Dave Witten are working on. So hopefully we'll have some sort of actual dashboard for that. So that is the report from the magnetometer lab group.
Nathaniel, I have a couple of things I meant to bring up.
Yes.
First is we have a very active sunspot on the sun right now. It's already put out 2 X-class flares, including an X8.
Wow.
And it's continuing to grow, and it isn't even pointing at us yet. So stay tuned.
All right.
The other thing is, Nathaniel, I just came across the posters from Hamvention, which I was supposed to send back to you.
Okay.
Is that something you would want for Hamcation?
The Hamvention posters?
The Hamvention posters.
I mean, are you coming to Hamcation?
I am not.
Okay.
I was going to send them back to you.
Yeah. I don't think I think we have enough planned already, so I don't think it's necessary. But or you can just bring them with you to the HamSCI workshop and you can hand them off there if you want.
Okay, that's fair enough too.
Yeah, that'll work.
if you don't need them right away. But I
Yeah,
realized you might have wanted them for
yeah. I
amplification, in which
I
case I
don't.
could ship them back.
Well, thank you. I don't think we are in a pressing need for them.
Very good.
All right, thank
I'll
you. I
bring them
appreciate
to,
it.
yep.
Yeah. And so, I guess while I have the floor, I wanted to ask Rob Robinette. Rob, have you heard of something called Mesh Central?
No, I hadn't. I did in the interval. I did go look at them. I don't have, I don't. It's obviously I'm sure very well implemented. I'm not sure what features it offers, and to be frank, I don't have time to reinvent it.
Mm-hmm.
To reconfigure it. So if someone wants to take on and use it as an access mechanism to the Whisper world,
Mm-hmm.
or the ham slice daisy systems, it's fine with me. I'll help what I can, but I just can't take the lead in it. I just don't
No,
have, you
and
know.
that's totally fair. So I think maybe we can find someone who is interested in working on it, or maybe we can work that into the
Yeah.
work package with the Alabama group, as part of as part of this charrette. The takeaway message from it is that I got from the IT group at Scranton. So what Mesh Central is it is an open source remote computer management package. And so it's specifically designed to solve a lot of the problems we have. So you have one server that's running the server like aggregator system, and then you install client client software on all the computers that you want to control. They all phone home to the main server. You end up getting a dashboard or something, and then you're able to bring up either a command line or like a remote KVM sort of situation of the remote systems.
Yeah. Okay,
And
but one of the if that's the limit, I mean, if that's the nature of it, it misses one of the key functions that we use, which is
mm-hmm,
the remote access to the Spectrum and
right.
K9Q web space. So I don't know. Perhaps they have a mechanism as part of it that would allow you to do that, but basically,
Mm-hmm,
um, the um, from what I see, well, I didn't see much, so I can't comment. But that would be one to ensure, because the most important, for many people, the most important thing is seeing their and listening to their radios
right.
remotely.
Mm-hmm,
And I don't know how that would fit into Mesh Central. I mean, perhaps they have that capability. I just that
mm-hmm,
would be the first point to look for, because
yeah.
basically, um, um,
But now a couple of things though. That system that you have for doing the remote forwarding the um of the spectrum, the SDR, that is entirely implemented over um fast reverse proxy, right?
yes,
And
yeah,
that does not use WireGuard at all, right?
that's right.
And so I think so basically you can set up a system that only uses fast reverse proxy, and you can handle the forwarding of the spectrum.
Yeah, I just asked a sec. You have one mechanism you have to configure to set up the remote access to the web page, and
Right.
another one for remote access to the SSH, terminal access.
Okay.
I mean, that
So
seems to complicate things. I don't know how that adds security. It seems to add complexity without adding security.
so from I think I certainly need to understand this a little bit more, but from talking with them today, they said that a lot of that this particular protocol does is set up for a zero trust environment. It would take care of a lot of the security issues that the enterprise people are worried about. So
Yeah,
they
I would like to understand that because that fundamentally, as I see the security issue, is as soon as you, whether you use Mesh Central or anything else, as soon as you have SSH terminal on somebody's server sitting in their home,
hmm
I can, I'm root. I can be root on that server sitting right behind you right
right.
now. Okay,
Yeah,
and whether it's Mesh Central or
right.
my SSR, based on SSH, as soon as I
hmm
do that, your security issues are the same. We have an open kimono in both cases.
Right.
So you know, I mean,
Yeah.
as I say, I don't really care.
Yeah.
You can use it, but
Yeah.
I mean, I've been 7 months into database stuff. I've got another month of database stuff to do, and
Yeah.
then I've got the client to rework and re-architect.
Okay.
So I just, I have all the functionality, and I believe the same levels of security as you would get from Mesh Central. But
hmm
they don't know what I can understand from an IT department standpoint. I don't know. I thought I gave them a pretty good explanation of how the current system works. So I don't know if
And you
how they're,
did.
yeah.
They did like that. But I think there were I don't think we can I don't think we can address all of the issues on it tonight. But I know that was
Uh,
something that came up today.
Okay.
So yeah.
Well, if
Anyway,
they want to
I
talk to
think
me, I think it's really a question of, yeah, I really don't want to enforce the way I've done it on the HamSCI, but
mhm,
I don't think I want to re-implement something unless there's a really compelling reason for doing so that someone can explain to me.
okay. That sounds good.
Okay.
Got
Sorry,
it.
but I'm sorry to
Yeah.
be.
Oh no, no, I understand. We may end up having another discussion during the day at some point when we are better rested, and I may have the IT people on the phone too, so we can all talk about it. But I think that was something I just learned about today,
Yeah.
so it's something we can think about. And I would say for the moment, just keep doing what you're doing, and
I'm not. Fortunately,
yeah,
a function that just worked for me. So
yeah,
I
yeah.
actually did some work to. It's now a GitHub project. There's a WD Rack GitHub project
Okay,
on my GitHub page. I believe I made it a private, so it's not immediately accessible to or visible to people. But
okay,
but it is checked in, and I'm happy to add you to the access, give you access to that, or and the IT department access to
yeah.
take a look at it. But but so I did some work on it, but it was mostly just to so there's I created an installer and I encrypted all of the information. So there's requires the user to provide passwords. So I increased the security of the system, but I think that was already described in the document I gave you.
Okay. Would it be possible for me to have access or be able to view that repo?
Yeah, yeah,
Okay.
sure. Yeah, of course. Yeah.
Yeah.
Yeah. I'm happy to share it. It's just I didn't want to make it available to the public.
Yeah.
There's there's no private information there, so
Mhm.
even if I were to make it public, it would not make the system vulnerable, um, because all of the security sensitive information is encrypted. Uh,
Yes.
and requires a password, which so far only two or three of us know. So,
Yes. That
but
sounds very good.
and you're welcome to know it as well. So
Okay. Well, thank you.
uh, you
Yeah.
know, it, anyway, I'll do that while we're talking.
All right, thanks. Yeah, my it's just my call sign is my GitHub username, so.
Okay.
So I think those are the main things I wanted to talk about tonight was the
Uh,
um yeah, I wanted to mention the Mesh Central. I wanted to uh encourage a few more people to submit to the HamSci workshop, and I wanted to give the update from the magnetometer group. So the floor is back for the taking. So back to the group.
Well, let me jump in, take a couple minutes to show my work on the RX888 replacement. I'll start out, let's see if this works. Okay, it says I'm screen sharing. Do you guys see? Boy, I can't see you anymore.
I
What
do.
happened?
I see it.
Okay, so I'm just gonna go, this is the circuit board. Um, this is a 6-layer board. I put everything on millimeter centers, and this is the first one I've ever done with the ball grid array. So you can see the outline here. There's the USB 3-port. We were talking about regulators. I just ended up sticking 4 of them. One, splitting the 3.3 volt load across 2 regulators. They are tied together with diodes. So the supply on, they'll both come up, force them to both come up at the same time. The other pair is a pre-regulator for the 1.2 volt regulator, which otherwise would be getting perhaps excessively hot. You'll see how this works. And I've got 4 SMA jacks here. Right now, this one here is not going to be installed. It's just sitting there in case at some point we do want to go balanced input, have to reconfigure part of the design in order to do that. Right now, this is basically going from not quite DC, but very low frequency, no transformers in the in the signal path. So let's turn that off. Okay, here's my main ground plane. Here's my main power plane, which I have broken up into different sections for the various 3.3 and 1.2 volt sections. And here and there, most of the sensitive circuits, I've got a series inductor and a shunt capacitor bypass. And sometimes I just run traces. Other times I'll do a island in the ground plane for that. And here's internal layer where I'm doing some secondary routing if I can't do it on the bottom layer. Here's another interior ground which separates some of the signal layers. And here is the ground plane. Oh yeah, I should zoom in here. So you can see the ball grid array gets a little bit nasty in there. I thought I'd have to use via in pad design, but I was able to just use micro vias in between the pads and get everything in and out. So that's that. And then I should be able to show you here on the screen. This is what the board is supposed to look like when we're done with it. And this is the back of the board. You can see I've relieved the solder mask on the 4 heat sinks, on the A to D converter, and on the VGA, the controlled amplifier. I was not able to relieve the ground plane or the solder mask, I should say, sorry, underneath the X3 USB interface port chip, I mean, just because of design rule violations. But anyway, so that's the design. And let's see, how do I stop sharing?
I think you said it, but can you just repeat what were the 3 SMA jacks?
Oh, and actually, I didn't say. Thank you.
Okay.
Well, I said, okay, here we go. Here's the input, RF input.
Okay.
This is the spare in case we want to mess around with later on with balanced input.
Okay.
This one here is the reference clock input.
Okay.
And this looks a little bit complicated. I just reused a circuit I've been using elsewhere. And what this does is this is the SI5351 here. This is the 27 megahertz TCXO, fairly inexpensive oscillator. But if you stick an input clock into here under this port, This will detect it and then switch over to your squared up input signal, and that becomes the reference clock. So we don't have an internal jumper. You don't have to take it out of the case. You just
Can you read the state of the switchover in software?
um yes, I want to do that on this board. I haven't yet. It just means running one more trace, and I need to talk to somebody about um probably Franco or maybe you, Phil. Which input would you like me to use on the
Well,
USB interface chip?
anyone I can get my grubby hands on in software, I actually don't know how that works.
Yeah, so I'll
Franco would be
ask
the better one.
Franco.
Yeah.
Franco's been very polite and helpful, putting up with my questions. So that's another. But yeah,
That's the kind of thing that's
I've
really
got.
important to log, to make sure that you're actually getting the
Yeah,
clock
no,
that
I
you're
I
getting.
agree, and I've got that signal. I've got a logic level for that signal, just ready to run over to the to be read by software. But I don't have that connection done. Won't be particularly hard to do it. I mean, every single trace I add gets a little bit tougher, but not I haven't hit the wall yet, so I I will be doing that. And so I guess
And
What's
if
the
then,
anyone
third
has
jack
any,
for?
yeah,
I'm
what's the
sorry.
third jack?
The one in the middle. That one.
Well, this is. Oh yeah, right. Okay. Remember, this is the time sync injector port. If we want to do that,
Okay,
and it
good.
um, so it just some attenuators, resistive attenuators, and then it just puts it in on the output of the filter and the input to the gain amplifier.
So then
Um,
we won't need a separate time sync
you'll
box
still
at
need a
the.
source. You'll need a source for the time sync,
Okay.
but you
But
won't need
well, when you say a source for the time sync, that's like a two-port Leo Bodner, right?
it. No.
Yeah.
That's the RF. This jack here is the RF input. So what you would use would be, for example, this box that.
You don't have a 1 pulse per second?
No, there is no 1 pulse per second going in here because that
Um,
would require a second synthesizer and modulation of that.
no, depending upon how you encode it.
What about the 5351? Are you using all the outputs?
No, I'm only using one output, but look, guys, this is my
Future creep.
goal.
Sorry.
No, it's all right. No. These are things that I was always considering, and I just ended up throwing away a whole bunch of perfectly good ideas because I wanted to get this thing to the
Build
point
it.
where we have the
Yeah.
basic
Yeah.
radio working. Even
Build
this
it. Build
time
it.
sync, even this time sync injection. The only reason I did it because it's like 6 resistors, and I wanted to keep I had a space for the connector. Otherwise, I wouldn't have even bothered with that because, let's see if we can get the radio to work. There's enough room on this board that we can start adding features if we decide we want them. Um, one difference from this from the RX-888, the board's physically bigger, maybe almost twice the size. Um, I'm using those 603 components. All the surface mounts are basically that. The RX-888 uses 402s. The 888 has some components on the back side of the board, basically bypassing around the fast ICs. I'm taking a risk here, doing my best to run bypass, but all the components are on the top side of the board. I think it'll be okay. All the traces are really short and good capacitors, but we'll see. Hope we don't have
Would
to do
shielding around the
two-sided.
clock be something you consider?
I'm sorry, say that again.
Shielding around the clock, is that something you might consider to
I'll
minimize the
can
amount of?
I'll consider it if it turns out we need it. I'd really like to see how this thing works as it is. You can't really see it here, but it doesn't help for, capacitive coupling, but as far as ground plane, ground loops, if you will, I've got isolation paths. I've got cuts in all the planes to isolate the RF filter section, to isolate the preamplifier section and to isolate the 5351 clock generation. So it's almost like single point RF ground. Um, all the
Where's the conversion to differential input on the A to B made?
it's made in this preamplifier chip going single-ended into it, but it comes out differential, and then here I'm running the differential traces into the ADC. So we're throwing away some don't have a transformer at the input. We're just running 50 ohms in. Um, the impedances we're going to be throwing away some gain, but we don't have a bunch of RF switches. We don't have that RF attenuator chip, which, even at 0 dB, it's going to have some attenuation. So, we'll see if we need to do something later on. If this is revision 1 of the board or revision 0. So anyway, that's where we stand now. I I would like to share the design, schematic and layout with anybody who wants to review it, with the understanding that you're going to really have to twist my arm to add features. But if anybody sees anything that they believe is going to cause a problem and it can be addressed, I'd like to hear about it.
I'll look at it, sure. I'm going to
Great,
program this
thank you.
thing.
I don't have a GitHub page. Maybe I'll try to set that up, and put the files there. I'll put them somewhere at the very least, and provide a link to that. Maybe it'll be GitHub.
And what are the thermal paths out of those two big chips?
Um,
What do
Thermal
they look
pads.
like?
See if I there the U pardon me, USB interface chip, the FX3, does not have a back pad. There's going to be we'll probably use that thermal pad material over
How
all of
how
the
is
board,
how is
really.
the chip mounted? Is it ball grid array? Is it what?
Yes,
Okay,
that's a ball grid array. So it's got pretty good. Yeah, but this square here, that is the ADC, and that's maybe the hottest thing on the board, other than perhaps the regulators.
so it would be good to suck heat out of that little square.
Yeah, and just the thermal pad itself will do that. Um, but this way, at least I don't know that the solder mask has that much thermal insulation characteristics, but I relieve the solder mask there just in case we get a few tenths of a degree improvement, um, with direct contact to the copper. And these, I don't know if you can see them, a bunch of, basically through hole grid array on both of these chips, and also to a lesser extent on the heatsink areas. And underneath, there's square plane area that is in all 6 layers, oh, except for the top layer. And the vias are connected to all of them and go through. So it's got should have pretty good copper thermal conductivity from the top of the board back to the bottom of the board, where we can then use the heatsink pad, or, I don't know. We'll see how the temperatures look, maybe glue on a little low
I don't know
profile.
the design rules for these things. The vias actually carry a significant amount of heat.
If you use enough of them, they're copper. Honestly, I don't know, but it's better than doing nothing.
Hmm.
Is that exposed copper where if you wanted to, you could solder something to it?
Yes.
Second question, has anybody got a thermal camera and looked at the current 888 just to see?
Yes, I
Boy,
have. I have. It's
Yeah, Rob has.
yeah, in free air. I mean, if in free air, the chips all run around 55 C. I mean, we're not the chips, the cases, right? Are around 55 C. If you
the epoxy case, yeah.
Okay, if you put it inside the box with the um, additional thermal pad, they seem to run about 70C. And pretty much all of them do. The linear regulators are the worst. I've seen them up at, I think, nearer 80C.
Have you ever shared those photos, those pictures, those images?
I don't have photos. I've just got one of those cameras, and I've one of those trigger things that reads out.
Oh, no, I'm talking about an imaging, thermal
Oh
imaging camera.
no, I don't have.
I've got one. I don't currently have a running 888 here that I could set up. But yeah, I've got a little IR camera that plugs into my smartphone, and it is really useful. I've used it on other designs, and I will be using it on this board. But yeah, we could now, those copper on the stop. Pardon me, let me get mute here. Okay. Those, yeah, I'm not sharing the picture anymore, but those pads underneath the heatsink, those copper areas, those have got voltage on them. 3.3 volts or 1.2 volts. So, just, have to be careful. They're not insulated, but the heatsink pad won't care. So anyway, that's it. So I'll try to get the design files available for review, um, and tomorrow or the next day. So back to anyone else.
Thank you, Paul. Really, thank
Yeah.
you for working on this. I want
I
to.
I agree. This is amazing. I'm going to ask a couple of questions that are very high level project manager type of questions. First of all, would you want to talk about this at all at the HamSci workshop?
Uh, I'd be happy to talk about it. I hope we'll actually have some results, be they good or bad, by then.
Yeah.
One thing you'll notice I haven't even mentioned is how's this thing going to get made? I mean, it's got an expensive analog to digital converter that, may or may not be in stock somewhere. And I understand, I haven't looked at, yeah, I think maybe I did check there's what is it, a 14-bit variant in the same package that
Mm-hmm.
I don't know if that's available, but so we need to figure out, this is done, the design rules are such that JLC or most anybody could build it. Most of the components have got JLC part numbers, not all of them, but um, actually, except for maybe one or two, they all could have. I just haven't finished the job of getting the part numbers. So
Yeah.
anyway, so we need to decide how this is going to be built. I'm assuming this is going to be a TAPR build, and I'll need to talk with Dave and probably John Ackerman and
Yeah.
George, and to see how we want to organize that.
Yeah.
And
I
it's not going to be, it'll probably be the most expensive board I've ever done, mainly because of the cost of the analog to digital converter.
when you say it's expensive, I mean, is it fair to ask how much you think it's going to cost?
No, it's not fair to ask because, well, it is, but I don't,
I'm asking all these impolite
I've done
questions, right? When is
I'll
it going
have,
to be done? How much is it going to cost? Very
yeah.
impolite, yes.
The only real, the FX3 chip, I forget how much that costs. It isn't a whole lot. The ADC was, what was it? 120 bucks or something like that. I don't recall.
Seen them
Hmm.
all over the map. Yeah.
It's, and you add them up, I don't know, three, 250, $300, maybe more, maybe less. And that's one of the things that I
And
said I would
that's
do, and I
just
haven't yet,
yeah.
is, and that's, and then we got to talk about, okay, what kind of case do you want to put this in?
Yeah.
I've designed it so it'll fit in little case that I use,
Mm.
which isn't exactly great because if you want to glue a heat sink on it like the 888 has, this is kind of the bottom of the case. The top's got these little thermal ribs on it, but we ought to see what the temperatures look like, and then we'll figure out. Again, it's a prototype. I've got four
Yeah.
mounting holes in the corner for screws, so we can
Yeah.
bolt the thing
I
onto a massive
I
heatsink if we
I mean,
want.
I think if you talk about this at the Hamsci workshop and yeah, show if you have some demo to show, I think that'd be really cool.
Well, I can put in a placeholder for that. Or it's, talk about work, we can talk about work in progress, and
Yeah.
how much progress there is,
Yeah. I
we'll
mean,
know
even
when
if
we
you
get there.
I think, so you're talking about yeah, the time of flight. Yeah. I think I think the Hamsci workshop really wants to see this thing.
This is my least favorite project, but I'm doing it. I hope it works. I
We can
really
talk
hope
about
it works.
giving you two presentations if you want. You can do one about the time of flight if that's your favorite thing.
I think I'm gonna hold this 888. I'm gonna hold it hostage, and you're gonna have to let me talk about time of flight.
Or wait, here's the way we could do it too. We could say I'll talk about time of flight, and then you can also say, by the way, we have this thing here that we're working on, and I have a little poster with some pictures on it and some
I
schematics, and come talk to me in the
tell
corner about it.
if I end up going, and I'd like to go. Tell me what tell me what you want, and
Yeah,
I'll deal with that. But I
yeah,
think time of flight's it's something new. I mean, this
yeah,
is if it works, it's useful. It's a second source.
yeah. What
I
what
hope
would
it's
you
more reliable.
what about doing what I just suggested, where you give the oral presentation about the time of flight, and then you also have like a poster where you just, and by poster you just put up some schematics and pictures, without a whole lot of words, and then during the poster session you can have your little RX, your X888 prototypes, and you can talk to people about them.
That sounds wonderful. I mean, no, I'm pretty flexible about this stuff,
Yeah.
really. But
Gary, yeah. Gary, what do you think about that plan?
I think we should. I think that's a great way to handle it. That way, we get the best of both worlds.
Yeah.
okay, I'll put something together.
Too late. I already have you on the schedule, Paul. Too late.
Okay. Oh man, I hope this thing works. And we need to build one. So I haven't, but
Yeah.
first
And
I really want I
I
really
can
want
tell
a
you that
design review.
the MIT Haystack people are planning on coming to this conference and are planning on giving presentations, and they're going to be really good people to talk to about things like time of flight measurements, and how are you doing your pulse per seconds and architecture. Like there's going to be really good people to talk to at this conference about this. So
Yeah, no, I'm definitely looking forward to that.
yeah.
Um, One thing about time of flight is I really need to get some help from Scott Newell on this, because he is doing the complicated part of it, and Gwyn and others, analyzing the results, and we've got time to pull together, enough of a presentation so that there's a little bit more than just me and my hardware gadgets. Um, but and I can do hand waving, just discussion of
Can you
what's
give
being
me
done
a
in the software, but
can you give
really
me a
need.
wish list of what you need from me?
Yeah, I
I mean,
know you.
not right now. If you can send me an email saying, here's
No,
what I need.
exactly. No, I know you got a day job, and I'm unemployed, so it makes it kind of tough for other people to.
And
But
I don't want to
I'll
leave you hanging out to dry on this either.
no, we've got time. We've got time. So yeah, I'll send you, maybe an outline kind of the additional information I'd like to have when I put this together. And, I
Yeah, exactly. That'd be terrific.
okay, I'll do that.
Yeah.
I mean,
Uh,
Paul, you talk about it this as being kind of a secondary source for our 888, but especially when combined with the your PPS injector, your time sync injector, that becomes, I think, to my knowledge, a unique radio product in the market. I mean, if I don't know how people would make such measurements. MIT must be doing this some way, but I don't think
yeah,
the high-end
it's
radios like Edis, I don't believe have this kind of
no,
capability.
no, and if we get the fundamentals of the triple eight of the X88, I
Yeah,
shouldn't call it X because X kind of stands for transmitter, but anyway, um, get the fundamentals of it working, then we can add stuff and subtract stuff. Like I put in my front end filters, the 60 megahertz and the shelf, just 'cause it seems that's really commonly done. When you use the triple eight, you want the front end
yeah,
filters.
absolutely,
So I
yeah.
put them inside. But if and
But
hell,
you
we're
made
not
a
even constrained to this form factor. We could put it in a still larger box if we want to add more features to it, like time of
yeah.
flight capability. Anyway, I want to get this thing working the way it
Yeah,
is.
I think you should. You're doing absolutely the right thing. Build what you and debug what you have, and but I wanted just to encourage you that this is not a side project. I think this could be a fundamental contribution to certainly citizen radio science,
Hmm.
and I think you should take
And
take some encouragement
yeah.
rather than
Absolutely.
just
And not
Absolutely.
just citizen radio science. Like I have colleagues, that are like, hey, when is we need replacements for the Edis N200s, some more modern technique, and they're looking for, how we're doing, the pulse per second with the RX 888, and they're looking for, what you're doing here. So
Yeah, but
this is
but no, I'm really pleased to hear this. But Hero, take a look. We already have okay this thing here. For example, there we go. This is my time sync box that just plugs into a receiver. You don't need the Bodnar. Um, well, you don't need two Bodnars anyway. So we got ways to do it even now without incorporating it inside the radio,
Did you say
inside the receiver.
that one had a microcontroller that could encode a time code?
Yes.
That would be wonderful.
Yeah, no, absolutely.
Um,
And I can,
some-
with the
something like
hardware and that little,
iRig H, I think, is the one that, well, I think
yeah, no,
WWV and
after,
WWVAB both use it.
yeah, no, I went and looked that up. Yeah, I wanted to ask you, Phil,
Yeah, one
if
bit
we
per
were to
second.
encode that in BPSK, um, they're doing stuff with, basically amplitude modulation to mark the start of the frame or
Right.
something like that. And with BPSK, you kind of don't know what's a one or a zero unless you do
Ah,
something.
oh, but you do. Okay, because if you look at the amplitude shift keying on, well, actually either WWV or WWVB, they invert it. On WWVB, you drop the carrier on the second, and then you increase it back to full power at some variable time later. With the subcarrier in WWV, it's the other way around, except that the first 30 milliseconds or so is chopped off because of the muting. But anyway, that point is that edge is always on time, and then it's the other edge that varies, and then you just look for that.
Yeah,
Right.
okay, the little box I showed you does not, the only amplitude control I have is on off. so we don't have
Well, it's
that
BPSK,
capability.
isn't it? Isn't it BPSK?
Yeah,
Well, then it means on or opposite on, right? On or
correct.
anti-on, right?
Yeah,
Yeah.
Paul, you just flip the edge at the top of the second, and then
Right,
you flip the other edge back at a variable time, 0.2,
right,
0.5, or 0.8.
right.
Of the entire, so we flip the phase of the entire sequence, and you have to you still need
You flip the carrier twice a second, on the second, and then either
Yeah.
200, 500, 800 milliseconds later, you flip it again.
Instead of every once a second, it varies, but you
Okay,
still
well
have to flip
yeah,
every
that's if
second.
we're using 1 hertz. We're
Yeah,
talking
that would,
about the iRig pattern, though. That's
yeah,
not just 1 pulse per second.
yes, it is. Well, what's 1 bit per second? But you have your choice of encoding it, right? I mean, if you look at the
Yeah.
spec on
Okay.
iRig, there's like it's a cafeteria, right? There's the
Sure.
data
Okay. I
format, and
was.
then there's the way you encode it, and
Mm-hmm. Okay. Well,
Yeah,
I'll
you
think
don't need
about it and I'll
AM. You
ask
can do it.
I thought
questions.
about this, so I think it's quite doable.
Okay. So I can, with that little blue box I just showed you, I can do better than 1 microsecond time accuracy if I put a pattern out on it, microcontroller sending the pattern. If we're just doing
So
pure
you can
PPS,
raise that on second edge within a microsecond.
oh yeah.
Okay.
If we're doing just the plain PPS, that's direct hardware modulation, and I can
Yeah.
stay within a few nanoseconds well,
And how
100
would it be?
nanoseconds because that's the GPS accuracy. But
Suppose you now need to take the other edge and vary its timing, pulse width modulation. 200,
yeah, sure. No, I've got
you can do that without
basically
affecting the accuracy of the on time edge.
I've got I've got basically millisecond right now. I mean, the software can change. I could run things faster, but right now I've got basically 1 millisecond granularity, or potential bit rate being 1 millisecond, or the period
What I'm
being
getting at
multiple
is
milliseconds.
that pin is controlled by software, right?
The Yes, the phase control pin.
Okay.
I've got two modes, but in the software controlled mode, yeah, it's controlled by software.
That's what I'm getting at. I mean, would there be some variation in the software be hard to control that would affect the timing of the on second edge of the time code?
No, I can start anything with 1 microsecond accuracy, and I can change the data pattern at basically 1 millisecond intervals if I want.
Okay, yeah, I mean, because that actually, I mean, the exact width of the pulse is not critical. I mean, you just need to be able to tell the difference between a zero and a
Oh,
one
so
mark.
Phil, are you proposing he uses the PPS from the GPS for nanosecond accuracy on the on second edge, and then do software on the less critical edge that could be a few milliseconds off?
Well, that's what I was trying to get at. I didn't know how
That would
his
be
software
terrific.
structured. That would be terrific. Yeah,
That No reason I couldn't do that. I
yeah.
got control of, which source we're using.
So you could
Basically,
flip
one
it
is a one
dynamically.
shot that one shot whose time is under software control, but is triggered by hardware by the
Yes.
one GPS. That's what you want.
Yeah, I might have a phase uncertainty issue there when I switch modes, but we can.
Well, phase
But
uncertainty
if
is
we're
not a
doing
problem. I mean,
if we're
I
happy
would,
with microsecond accuracy, then we can do anything
yeah.
with.
Well, it all depends on the bandwidth of the channel you're going to run this through, and it probably
Yeah.
won't be, more than a megahertz. So,
Yeah. Well, I sort of put that on hold while I was working on this receiver, but uh, pretty soon I should be able to jump back into this, or at least devote a little bit more time to it and see what I can come up with, and I'll run it past you
because
guys.
the more I think about it, the more I really like this idea of an in-band time code that goes through as much of the signal processing as your actual channels. The more, the better.
So, okay, Phil, so how does that help you if you're the time beyond just playing the 1 pulse per second, because you're using a radio, the K9Q is software is running on a computer that, unless it does not have internet access, it can get timing down to the 1 second level pretty,
Right.
time of
That's
day and
correct.
all that. So it knows
That's right.
that. What it
That's
doesn't
right.
know, what it doesn't have is timing down to the, microsecond,
That's
which
right.
is
You're
what
right.
this time sync can do.
You're
But
right.
that's a plain pulse per second time
You're
sync will
right.
do
It's
that.
just that it simplify. It does simplify things in a practical sense, right? It's just one less thing I have to set up,
True.
and one less connection that has to be set up to
Okay.
carry that time code.
Yeah. Anyway,
Um,
it's not a particularly difficult challenge to send the time code, encode it and send it. So it's worth looking at for sure.
I mean, I thought I may actually just do a. I've been thinking about this for a long time, just doing a WWV timecode receiver as a demonstration of multi-channel diversity. Where you
Yeah,
receive all 6 channel HF channels and then combine them using an algorithm called maximal ratio combining, where you combine according to their signal noise ratios and you get a weighted sum. And
right.
you get a signal that's a signal noise ratio is better than any of the individual channels by themselves. I mean, the best case, like if you have 2 channels that are equal strength, the output would be 3 dB better than either one of them.
Isn't that kind of what Michael's doing with
Yeah,
his
yeah.
multi?
Michael's doing that. He's
Yeah,
Yeah,
done it.
it's an old technique. Yeah.
Yeah,
yeah.
Michael has done it. He's
Yeah.
so it might not be the most. You might want to look at what he's done before you.
Michael, wait a minute. Michael, wait a minute. He's
How
done this
Mac?
on multiple channels with combining or diversity?
Yes, no, multiple channels. He does all 6 WWV and all 6 H and all 3 CHU and
Yeah,
some
yeah.
from does all of them
I understand.
simultaneously.
Okay, I
And then
understand that. But the question what I'm getting at is, does he do maximal ratio combining of those of
he
those
does.
cables?
He does. Yes, he does. I don't know that he does
Well,
maximal.
that's
He
what I'm
does.
getting at. Yeah,
He was doing. I think he was using. He uses a Kalman filter as a
yeah.
way to do that.
But
Perhaps
I think he was doing a weighting of the multiple inputs based on SNR
That
to.
yeah,
okay. That's what I was getting at. That's what
yeah,
I'm
Yeah, I
getting
yeah,
think
at.
yeah,
so. I
That would
think,
be maximal ratio combining.
yeah,
yeah, I
yeah,
recall he mentioned something like that.
Yeah,
yeah,
I dug up the paper on that. It was invented by Leonard Kahn back in 1954. The guy invented like AM stereo. That guy.
yeah. Ah,
Yeah, he was the one who came up
well,
with that.
anyway, that Michael has a GitHub project on this.
Okay,
It's
I'll
part of.
check it out.
Yeah, so he's. I'm sure
Sounds
he'd welcome
profitable.
he'd welcome.
Yeah, I mean,
He'd certainly welcome the comments
There,
and
I should also,
suggestions.
yeah, also on Michael's project, we actually have a new telecom research group working with him to evaluate that project. And so that group just started up about a week or so ago, and that involves Anna Montare and Sarah Over from Virginia Tech, and Christina Collins might be involved in that too. But they're working with, and I think John, I think yeah, Michael Howen is working with them to kind of evaluate and test all this more thoroughly.
excellent. That just reminded me. She just sent out a invite to another WWV meeting
Yes.
coming up in a
Yeah.
week. Yeah, on the
Yes.
10th. Yeah.
Yeah, I saw that.
Hey guys, I guess I'm gonna bail unless you got anything else for me.
I
But
think
this
I'm
shouldn't
gonna
be the
go
Paul
too.
show here. Come on, you guys. I'm sure you got other stuff to talk about.
I think this is really good. I'm probably gonna say 73 for tonight too. But
Okay, Gary, I will. If you still here, Gary. Anyway, yes. I'm just saying, I'll send you an abstract, and looking forward to doing this.
Yeah, the time of flight thing, the abstract for the talk, because that's where the scheduling difficulties are. We can always fit in another poster. So if you could do the time of flight thing, focus on that. That would help.
Okay, we'll do. Okay, good night, everybody.
Good night.
good
Yeah.
night.
73 all.
Okay. Well, we ended early.